Look at the exam paper in front of you. You might think you're just sitting down to answer some physics questions, right? Well, what if I told you there's an actual blueprint to legally stealing the examiner's mark scheme? Let's get right into it. Today, we're executing a complete mark scheme heist for Cambridge IGCSE Physics 0625, and we're focusing entirely on a notoriously tricky section, refraction and total internal reflection. We are absolutely not just memorizing facts here. We're reverse engineering the grading system to guarantee your points.
So why target this specific topic first? Because refraction and total internal reflection accounts for roughly 15% of your total exam marks. Yeah, think about that for a second. That 15% is a massive grade boundary risk. It's literally the difference between an A and a B, or even passing and failing. You see, ordinary revision completely fails here because students tend to treat it like a simple vocabulary test. But the syllabus, it strictly emphasizes that top-performing candidates have to demonstrate multi-stage analysis. If you aren't prepared to systematically break down multi-step problems, you are just leaving easy points on the table.
To execute this heist flawlessly, we first need to quickly secure our theoretical architecture, and this requires surgical precision with your definitions. Let's look at the critical angle. It is specifically the angle of incidence in a denser medium for which the angle of refraction is exactly 90 degrees. Missing that phrase in a denser medium or forgetting exactly 90 degrees means you're instantly dropping the mark. Examiners are looking for precise causal relationships, not just vague guesses.
Now, this directly builds into our second primary target, total internal reflection. This phenomenon happens when a light ray completely reflects back into its original medium, but only because the angle of incidence actually exceeds the critical angle. But here's the real catch, guys. Examiners won't just ask you for the simple definition. No way. They're going to hand you a strangely shaped glass prism or maybe an optical fiber and force you to trace the ray. You have to be able to carry this theoretical architecture into a practical, completely unseen problem.
So to guarantee you actually survive those practical scenarios, you need what I call the method mark strategy. This is a standardized 5-step sequence pulled directly from successful past exam performances. Step 1, deconstruct the command word. Step 2, extract the relevant data from the text and tables. Step 3, select your analytical formula. Step 4, execute with clear notation. And finally, Step 5, present your final answer with the correct units. Using this standardized sequence pretty much guarantees your points because it forces you to show your processing step by step no matter what they throw at you.
In a moment, I'll show you the ultimate examiner clue that changes your answer and your final score completely. Seriously, it's the single biggest safety net you have in this entire exam. But first, you need the analytical framework that makes that clue completely obvious when you're sitting in the exam hall under immense time pressure.
Okay, so this 4-step framework is your analytical blueprint for literally any high-mark problem. Whenever you face a question asking you to explain or evaluate a refraction scenario, you've got to structure your answer exactly like this. First up, clearly state the concept. Are we talking about refraction or total internal reflection? Second, pull the exact evidence or data straight from the prompt. Third, apply your scientific reasoning to logically connect the concept and the data. And fourth, finish up by utilizing precise examiner wording. If you follow this blueprint, you are literally writing the mark scheme for them.
All right, I want you to pause for a second as the stakes rise here. Imagine you're in the exam and you only have 2 minutes left on the clock. We're going to look at a scenario where a genuinely well-prepared student lost crucial points under that timing pressure. Think back to our blueprint: concept, data, reasoning, wording. Where do you think they dropped the ball?
Let's break this crime scene down. In the flawed answer, they correctly identified the final concept, sure, but they jumped straight to the conclusion. There's zero working shown and absolutely zero data extracted from the prompt. It's a classic panic move. Now look at the top-band execution. This student explicitly states the angle of incidence, compares it directly to the critical angle using the provided data, applies their scientific reasoning, and locks it all in with the precise terminology of total internal reflection. Boom, all points secured. So avoiding these exact traps, which, by the way, are pulled straight from the Cambridge Principal Examiner reports, is your absolute highest priority. These are the top reasons students lose marks on this specific topic every single year. Number 1, forgetting proper format. Number 2, not checking your presentation. Number 3, giving generic answers that just completely lack the specific context of the question. And number 4, the biggest offender of them all, no working shown. Let me be clear, missing formatting or lacking specific context will instantly drain your score. It will completely derail your grade, even if you conceptually understand the physics perfectly.
To make sure you never forget to check your formatting or extract your data when the exam panic sets in, here's a really powerful memory hack for you. Try creating your own mnemonic, using the first letters of key terms, or just use our framework letters, C, D, R, W. That's concept, data, reasoning, wording. Turn it into a rapid mental checklist. Before you turn the page to the next question, just run that quick checklist in your head. Did I state the concept? Did I use the data? It literally takes 3 seconds, but it saves entire letter grades.
And this perfectly reveals that ultimate examiner clue I promised you earlier. Listen to this direct quote straight from the examiner reports. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Showing your precise systematic working is your ultimate safety net. If you accidentally mess up a calculation at the very end, but your method is flawless, those method marks can entirely save your grade boundary. That right there is how you legally steal the mark scheme. You make your process so incredibly visible that the examiner literally has no choice but to award you those points.
All right, so we've successfully cracked the core mark scheme for refraction and total internal reflection. You've got the blueprint in your hands, but an unresolved problem still remains. If you don't know how these traps actually change based on the specific command words, like say, when an examiner asks you to evaluate a practical investigation versus just describe an experimental variable, you are still completely vulnerable on exam day. The traps shift constantly depending on the specific question type.
You need to know exactly how to pivot your strategy for data analysis versus a calculation question. So, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations, and follow the escape tunnel straight to our next explainer to master those exact question traps. You have the blueprint now, but can you survive the shifting traps? Let's find out.